Okay, so we're going to do a few examples of review for sections 1.1 through 1.3 for our quiz coming up. So take a minute, pause the video, and graph the following piecewise functions. State the domain, the range, the increasing intervals, the decreasing intervals, and any constant intervals. Okay, hopefully you got this as your picture. So let's talk about how we get this. Well, I'm going to look at my first piece here. The domain for this piece is less than or equal to 1, so that's going to go from negative infinity up to positive 1. So I'm going to start at positive 1. If I plug in 1, negative 2 times 1 is negative 2, negative 2 plus 1 is negative 1. So I start at the point 1, negative 1. That's a filled in circle because I'm including 1. And then this is a line. This is the equation of a line in slope-intercept form with a slope of negative 2. So I go up 2, left 1, up 2, left 1, and so on to negative infinity. Next we have the equation f of x equals 1, which is a horizontal line at y equals 1, between 1 and 3, not including 1 or 3. So at 1, 1, I have an open circle. At 3, 1, I have an open circle and a horizontal line in between. Then for the third piece, this is a quadratic function or parabola with a vertex at 3, 1, starting at x equals 3 and going to x equals 5, including both. So if I plug in 3, I get 3, 1. That's a closed circle. Notice that that's at the same spot where I had an open circle. That's okay. That's not overlap. It's still a function. And then if I plug in 5, 5 minus 3 is 2, 2 squared is 4, 4 plus 1 is 5. So that's going to be at the point 5, 5, and this is going to be a parabola in shape. So that's my graph. Now we want to talk about the domain. Well, domain is going to be negative infinity to 5, including 5. So how do we come up with that? Well, I know that this piece right here, the top piece, this line, is going off to negative infinity in the x direction because it's going to continue to go left forever. And then each piece of this domain connects to the next one, including that point, until I get to 5, including 5, and then I stop. The range is negative 1 to infinity, including the negative 1, and all of that comes from the red piece that I've drawn here, or the first piece of the piecewise function. So the lowest value here is negative 1, it's including negative 1, and then this goes up to infinity forever. Now these other two pieces are included in that, but I don't need to restate them because it would just be overlap for negative 1 to infinity. Then we want to talk about the increasing and decreasing intervals. Well, the blue piece, or the quadratic here, happens to be increasing, so it's increasing from 3 to 5. The purple, which is the horizontal line, or the middle piece here in the function, happens to be constant, so it's constant from 1 to 3. And then the top piece, which is the line with a slope of negative 2, is decreasing from negative infinity to 1. Okay, let's go on to the next example. So here we want to find all of the zeros, or I'm sorry, all of the real zeros, and find the domain of the function. So again, pause the video and try and do that, and then unpause it when you're ready to check your answer. Okay, so hopefully I did my math correctly. But first thing, I'm going to try and factor this entire rational function. So I factored the numerator as if it's a quadratic, so this becomes x squared minus 5 times x squared plus 2. The denominator I factored by grouping, so I pulled out an x squared from the first group, a 3 from the second group. And so the final factored form of this function is x squared minus 5 times x squared plus 2 over x squared plus 3 times x minus 1. Okay. So now over on the left here, I went about finding the zeros. Now remember, we're trying to find the real zeros, so we can ignore imaginaries. Well, to find zeros, remember we first set the function equal to 0. Now, my next step, which I did not show, would be to multiply both sides by the least common denominator. The least common denominator is x squared plus 3 times x minus 1. So that goes away. So I'm left with 0 equals x squared minus 5 times the quantity x squared plus 2. Because of the zero product property, I can set each factor equal to 0. So I get 0 equals x squared minus 5, which gives me x equals plus or minus the square root of 5. And I get 0 equals x squared plus 2, which is going to give me imaginary solutions or complex solutions. Therefore, I can ignore this, and my real zeros are x equals root 5 and x equals negative root 5. Now, what about the domain? Well, the domain, remember what we're looking for is where does the function not exist? So in this case, where is the denominator going to equal 0? So I set the denominator equal to 0. So 0 equals x squared plus 3 times x minus 1. 0 product property tells me 0 equals x squared plus 3 and 0 equals x minus 1. 0 equals x squared plus 3 is going to give me imaginary or complex solutions. So I really only care about x equals, or 0 equals x minus 1, which gives me x equals 1. So x equals 1 is where the domain does not exist. Therefore, my domain is going to be all real numbers except 1. Or I can say negative infinity to 1, 1 to infinity. Any questions? No? Okay. You guys have been quiet today. Alright, next one. So here, take a minute, look at this graph, figure out the domain and the range, pause the video, write down your answer, and then unpause it when you're ready to check. Okay, so hopefully you got the domain as negative infinity to negative 5, including negative 5, and negative 1 to infinity, not including the negative 1. Now, how do we get that if we did not get that answer correct? Well, this piece right here is going to continue to go to the left forever, so I know I'm starting at negative infinity. Now, as I trace this to the right, this piece stops at negative 5, but it includes negative 5. Now I have a gap in the x directions until I touch right here. This is at positive 1, so I apologize. We'll call it a typo. So this should be 1 to infinity. So here we're at positive 1, and then it is not including the 1 though, because that's an open circle. As I trace this to the right, it stops at but includes 5. However, that's not a gap, because this piece now jumps down here, starts at 5, not including 5, and then goes off to infinity in the x direction. So that's how I end up with 1 to infinity. Now the range I want to work from bottom to top. So this is the lowest piece on the function, and this is going down, so it's going to negative infinity. So as I work my way up, this piece stops at negative 4. It's an open circle, so it does not include the negative 4. Now again, I have a gap until I get to this piece here. This starts at negative 2 in the y direction. It includes the negative 2, and then it goes off to infinity in the y direction, because this is going to go up forever. I don't need to restate this piece, which would be 4 to 6, because that's included within this interval of negative 2 to infinity. Alright, now here, determine if this function is even, odd, or neither. Show your work. Pause the video, check your answer in a minute. Okay, so remember to check for even or odd, we want to first find what is f of negative x. So I plug in a negative x wherever there's an x into the f of x function, so I get 2 times negative x cubed plus negative x plus 4, which simplifies to negative 2x cubed minus x plus 4. So f of negative x is negative 2x cubed minus x plus 4. That does not equal f of x, so it is not even. Now I want to check to see if it's odd, so I find negative f of x. Negative f of x is going to be negative 2x cubed minus x minus 4, which does not equal f of negative x, so it is not odd. Therefore, this is neither. Keep in mind, this is the amount of work that you will need to show on a test or a quiz to demonstrate to me that you actually understand how to find if something is even, odd, or neither. Okay, last one. So here I've given you a picture of a function. We'll call this function here, this is f of x. So therefore what I want you to do is I want you to find y, which is a transformed version of f of x. So pause the video and go through the transformations and unpause it when you're ready to check your answer. Okay, so what I have in purple here is the correct answer for y. Now, how do we go about that? Well, if you look at the original graph here, I've highlighted in red the points that I need to focus on. So I need to focus on all of the turning points, so here, 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 and here. I also need to focus on where is the graph 0. By 0 I mean where does it have a y value of 0. So that's going to be this point and then this point, which was also a turning point. The reason why I care about that is because I notice that now I'm using an absolute value. Notice that everything that's affecting this function, or every transformation that I'm doing, is affecting the y values. The order in which I'm going to do this is the absolute value of y multiply y by 1/2 and then subtract 2 from the y's. So if I look at this point here, this point became this. So first I do the absolute value of y. Well, what is the y value here? It's the 4 to start. The absolute value of 4 is just 4. Now multiply 4 by 1/2. 4 times 1/2 is 2. And then subtract 2 from this. 2 minus 2 is 0. Now I have to take the 0 point. So the absolute value of 0 is 0. 0 times 1/2 is 0. 0 minus 2 is negative 2. The absolute value of negative 3 is positive 3. 3 times 1/2 is 1.5. 1.5 minus 2 is negative 0.5. The absolute value of negative 4 is positive 4. 4 times 1/2 is 2. 2 minus 2 is 0. The absolute value of 0 is 0. 0 times 1/2 is 0. 0 minus 2 is negative 2. The absolute value of negative 3 is positive 3. 3 times 1/2 is 1.5. 1.5 minus 2 is negative 1.5. So that's how we come up with our new function.